Okay, so this is going to be a little example, another example of regression forecasting. And here we're just looking at the trend of gallons sold during the week. This was actually from the data set. It already came with a graph, a trend line graph. And you can see there's a reasonable relationship here. As weeks increase, the amount of gasoline sold increases. So we can kind of model this as a time series. So let's actually just build it officially as a regression model. So we have the week as the independent variable and the gallons sold as the dependent variable. We also know to have a space here. This is for when we want to actually um, forecast gallons sold given the week. And the other thing is we're going to add a second covariate. I'm just going to swap these around. So eventually we could build a model that incorporates a covariate. By covariate, I mean another variable. And let's just kind of work through the regression model. Okay, so let's go data analysis, regression. Exactly the same as what we did previous week. The Y is the gallons sold, and the X is the week. And this is the example on page 349. We don't want to worry about residual analysis for this example. We're going to put all of our, I think the previous regression was Z. I'm going to put all of our values here. Okay, so this is the regression output. I'll just update the font. And you can see we have an R squared of around 0.68, adjusted R squared of 0.64. And we can use that to compare when we add the second variable. And we've also have our coefficients, both, we don't worry about the intercept, but the week is significant. And we can say that for every increase in week, we have an extra 812.99 gallons sold with a base of 790.1. So let's just kind of build this model here. We have the week and the gallons sold. And then we can predict for week 11, we're going to have the intercept. As this is the only one I'm doing, I don't need to worry about dollars at the moment. Plus our coefficient, our beta 1, times by the week. So that's our prediction for gallons sold. Now, let's just see if we can improve the model by adding the average price per gallon. So let's go data analysis, regression. And here's the Y. And let's just have a look. The Y doesn't change, but this time we're adding both of these variables. And we're going to put it directly below the previous. Okay. Let's just update our font. Now you see, sorry, I try to. Okay. So multiple R squared. The R squared has improved from 0.684 to 0.865. And also, more importantly, accounting for the extra parameter, the adjusted R squared has increased dramatically as well from 0.645 to 0.827. And you can see here, if we're testing at alpha equals 0.05, obviously not if we're testing alpha equals 0.01, both the week and the average value price per gallon are significant. So you can say that this has quite definitely improved the model in terms of R squared. Now let's just do a little prediction with this model, again for week 11. So we've got the week and the average price per gallon. And we're going to predict the gallons sold. So the gallons sold is intercept plus the number of weeks, times by 508 for every week. And we can see the price per gallon has a negative effect, as you would expect. So plus this coefficient, which is actually negative, times by the average price per gallon. And we get 15,000. So this is slightly actually higher than this amount here, which was 13,700. And I guess this is because we've actually have prices per gallon at the low end. Again, you have to be careful with predictions in regression when you're outside the range of the actual data. So here we're lower than the previous data. So again, that could cause a little bit of inaccuracy there. But we do see overall that we've built this second regression model, and this second regression model, notice here the intercept's much higher, but the week increase is lower, and then this is counteracted by the price per gallon. Okay, so just that's a good example of time series regression and time series regression adding a